Okay, so let's take a look at, again, the difference between a stationary and a critical point, just to clarify. Here we have two functions where we're looking at where the slope is equal to 0 and where my graph comes to a cusp or a point. This is not differentiable based on our definition. However, here we can take the derivative and it is equal to 0. So remember, if f prime of x is equal to 0, this is considered a critical point and a stationary point. Okay, remember this is the subset, critical point and stationary point, and this is the highest point on the graph, so it's considered a relative max. Here, because you cannot take the derivative, where the derivative here is undefined, this is considered a critical point, but not a stationary point, because you can't take the derivative. Okay, and this is also a relative max. So again, the difference between the two. You can take the derivative, you cannot take a derivative. Critical point and stationary, only a critical point. Okay, let's talk about the first derivative test. Okay, so this is actually going to tell us a lot where we have a relative max and a relative min. So this is going to seem like a lot, but when you actually put it in practice, it's not too bad if you sketch the number line. So in this first part, this is saying that f prime of x is greater than 0, meaning your derivative is positive. Okay, you have a positive derivative here on an open interval extending left from x sub 0, and f prime of x is less than 0 on an open interval extending to the right. Then f has a relative maximum. Okay, what? So let's take a look. Here's my number line. Okay, here is x sub 0, which is what they're talking about. So it says extending from the left and extending right from x sub 0, we have a relative max. So what they're saying is on the left hand side, if our value is positive, okay, extending from the left to this value, and then on the other side it's negative. So that means before this critical number here, my function is increasing, and then after decreasing. This is the highest point on the graph, so this is a relative max right here. And this is in f prime. So what they're saying here is if f prime of x is less than 0 on this open interval extending left from x sub 0, okay, and f prime of x is greater than 0 on an open interval extending right from x sub 0. So let's draw this out. Here's x sub 0. So it says f prime of x is less than 0 extending left, going this way, meaning negative. The derivative is negative. And then in the second part it says, and the derivative is positive extending right. So you're going to the right here. That means the function is decreasing before that value and increasing after that value. So this is going to be a relative min. Okay, if f prime of x has the same sign on the open interval, meaning, for example, this is negative negative or positive positive, then there is no relative extremum. And just so we have a diagram, here's x sub 0. This is in f prime, so you might have positive positive, or you could have negative negative. Okay, meaning the signs are the same. So how do I use this? Let's take a look at this first example. It says find all critical points and then determine if these critical points are relative max, min, or neither using the first derivative test. Okay, so the first thing we do is we take the first derivative. F prime of x is equal to 3x squared minus 6x. Then we need to find our critical points by setting the derivative equal to 0. So in the meantime, I'm going to factor out a greatest common factor. So I've got 3x times x minus 2 is equal to 0. Okay, my critical numbers are found by setting the derivative equal to 0. So that means I get x is equal to 0 and positive 2. So I'm going to put them on a number line. Here's 0, here's positive 2. I'm going to test these intervals in f prime. So I'm going to use this factored version. You plug in a value below 0, okay? So negative 1. So that means I have a negative times a negative, which will make a positive. Plug in a value between 0 and 2. So when I plug that in, I get negative. 3 times 1 is positive, 1 minus 2 is negative. And then plug in 3. Pick easy numbers, this will be positive. So what does this mean? What this means is that on the interval from negative infinity to 0, f of x is increasing. Okay? Then from 0 to 2, f of x is decreasing over that interval. And then from 2 to infinity, f of x is increasing. Okay? So now what we're going to look at is when you go from increasing to decreasing, when the graph turns at 0, this is the highest point on the graph. So going from increasing to decreasing, you have a relative max. Okay? Then, when you're going from decreasing to increasing, this is the lowest point within your picture. So this is a relative min. So what we have to do is say that f has a relative max at x equals 0 because f prime changes from positive to negative. Okay, this is your justification. Then, in the next sentence, you would talk about 2. So you would say f, I ran out of room here, has a relative min at x equals 2 because f prime, that's where we tested, changes from negative to positive.